Imagine you're on the set of a high-stakes commercial shoot.
Okay, yeah. Setting the scene.
Yeah. You've got the perfect lighting, the talent is hitting all their marks, the camera operator is executing this, like, absolutely flawless panning shot. Everything is beautiful.
Right, a director's dream.
Exactly. And then, right in the middle of the take, your lead actor spontaneously grows a sixth finger.
Oh, man.
And the sun just instantly teleports from the east to the west, completely flipping the shadows. And to top it off, this solid brick wall in the background slowly starts to, like, melt into a puddle of gray mush.
I mean, you'd fire the entire crew on the spot.
Right. You'd be
It
furious.
would shut the production down immediately. I mean, it's an absurd scenario in the physical world, but that level of surreal, unpredictable chaos has basically been, well, the defining characteristic of AI video generation for the last couple of years.
Which is exactly why so many people, especially if you work in, professional media or enterprise marketing, have just treated AI video as a novelty.
Yeah, completely. Like a toy.
Right. It's a fun toy for making weird viral clips of, I don't know, historical figures eating spaghetti. But it really hasn't been a reliable tool for serious business.
Not at all.
But today, we are tearing that assumption down. Welcome to this deep dive. Today, we are looking at what I can only call a monumental shift in how digital media is produced.
And this shift is being driven by a very specific new open weights video foundation model, right?
Yes, exactly. It's called LTX 2.5, and it was developed by LTX and Lightrix. We are going to explore how this specific technology is dragging AI video out of that novelty phase, like we were just talking about, and turning it into critical enterprise-grade infrastructure.
Yeah, and the word infrastructure is really the key to this whole conversation, I think.
Oh, so?
Well, we are moving away from the era of treating generative AI as like a magic trick where you type in a prompt and just sort of cross your fingers and hope for the best.
Right, the old generate and pray method.
Exactly. What we are examining today is the transition to a highly controlled software pipeline. It is about taking the massive, expensive physical logistics of a Hollywood set and literally compressing them into deterministic, controllable code.
Which is just wild to think about. And if you are a creative director, a developer, or a marketing executive listening to this,
Yeah.
the implications are massive for you.
Huge. Absolutely huge.
We're talking about fundamentally changing how businesses operate at scale, right? How content is localized and even how brand identity is protected.
Yes, all of that.
So I want to start by looking at the core problem LTX 2.5 is actually trying to solve, which requires a bit of a paradigm shift. If you have ever played with previous AI video generators, you know the frustration. I always call it the slot machine effect.
The slot machine effect, I like that. It's very accurate.
Yeah, you spend, 20 minutes meticulously crafting this perfect text prompt. You pull the lever by hitting generate, and you just sit there waiting to see what the machine spits out.
And the machine usually spits out a highly isolated, totally disconnected 5-second clip.
Right. And for the first 2 seconds, you're like, wow, this is amazing.
Yeah, the resolution is crisp, the subject looks great, but then as the clip progresses, the internal logic of the video it completely collapses.
Right.
The model loses track of what it's actually rendering, so the character's face suddenly morphs into someone else entirely.
Or the jacket they're wearing magically changes from leather to denim halfway through the step.
Exactly. You get a lucky snapshot, essentially.
But a 5-second lucky snapshot is totally useless if you're trying to tell a cohesive story. You cannot build a 30-second product commercial or like a corporate training video out of random hallucinatory snapshots that don't even match.
You really can't, and that's where LTX 2.5 comes in. It approaches this by completely abandoning that slot machine dynamic through something called native multi-shot generation.
Native multi-shot generation. Okay, let's break down why that is such a massive architectural leap. Because historically, when an editor tried to use AI video, what did they have to do?
Oh, it was a nightmare. They would have to generate dozens of these isolated clips, drag them all into a traditional non-linear editor like Premiere Pro or something, and desperately try to stitch them together.
So forcing them to fit.
Right. They would use heavy color grading, rapid cuts, anything to hide the fact that the main character's face kept changing slightly from shot to shot. It was just a nightmare of post-production masking.
But LTX 2.5, on the other hand, is built from the ground up to generate connected sequences.
Exactly.
Meaning the AI actually understands that scene B is a direct continuation of scene A.
Down to the mathematical level, the model is actively preserving the specific latent representation of the character's identity.
Wait, what does that mean in plain English? blatant representation.
Think of it like this. If your protagonist has a specific freckle pattern on their left cheek, and they're standing under a warm amber street lamp in shot 1, the model locks those parameters in.
Okay, so it remembers the freckles and the amber light?
Right. So when the camera angle cuts to a close-up in shot 2, that specific freckle pattern and that exact amber lighting condition are perfectly preserved. It maintains the environment, the physics of the scene, and even the voice across these connected cuts.
Wow. I want to make sure I'm visualizing this correctly, because it sounds like we are shifting from being a frustrated photographer who just holds down the shutter button and prays for one good photo.
To being an actual film director who has total command over the physics of the set across multiple camera setups.
Yes, exactly.
And that director analogy holds up perfectly, especially when you think about the storyboard to rough cut gap in professional production.
What do you mean by that?
Well, for a long time, there was this fear, or maybe just an assumption, that the job of a creative director was going to be replaced by a prompt engineer.
Oh, right. Like someone whose only skill is just typing really, really descriptive sentences.
Exactly. But because LTX 2.5 mathematically guarantees the continuity between shots, the job actually reverts back to traditional filmmaking skills.
That makes a lot of sense. So the creative director doesn't have to spend hours tricking the AI into keeping the character's hair the same color.
Right, they can focus entirely on shot design. They can actually think about how a wide establishing shot emotionally transitions into a tight close-up. They are directing narrative pacing, not just trying to fix weird glitches.
So if the model is handling the continuity, that frees up the human editors to focus on the actual emotional resonance of the edit.
Which is what they should be doing anyway.
Exactly. But, okay, this brings up a huge technical question for me. Rendering video is incredibly computationally expensive, right?
Oh yeah, it burns a lot of power.
So if the model is maintaining all this complex continuity across multiple shots, how is it not just melting the GPUs? The data we are looking at points to a specific mechanism here, something called diffusion fidelity rendering.
Yeah, and this is honestly one of the most elegant engineering solutions in the whole model. To understand it, we kind of have to look at how standard uniform diffusion models work first.
Okay, lay it out for us.
Typically, an AI video model treats every single pixel on the screen with the exact same level of importance or computational weight.
Meaning what, exactly?
Let's say you have a video of a woman running through a field. A standard model spends just as much processing power rendering the blurry, out-of-focus clouds in the deep background as it does rendering the intricate motion of the woman's face and hands in the foreground.
Oh, wow. Which is incredibly inefficient. It's like hiring a master portrait painter and paying them their massive hourly rate to paint a flat white wall behind the subject.
That is a phenomenal way to picture it.
Wow.
Yes, the master painter knows where the viewer's eye is actually going to go. And diffusion fidelity rendering does exactly that for the AI.
So it's analyzing the scene.
Right. The model analyzes the structural complexity of the scene frame by frame. It identifies where the crucial action, the complex textures, and the human movements are actually happening.
And then it just shifts the power there.
Exactly. It dynamically allocates its computing power to those specific areas. It essentially budgets its brushstrokes. It doesn't waste precious VRAM trying to perfectly render a static brick wall in the background. Instead, it pours all that computational energy into ensuring the runner's hands look realistic and that the lighting on her face shifts correctly as she moves.
That's brilliant. And we obviously have the benchmarks to back up how well this works, too, because LTX 2.5 recently released their automated evaluation scores, and the pro version of the model hit a preliminary visual artifact score of 0.28.
Which is a remarkably low number for visual artifacts.
Yeah.
Now, for the sake of transparency, we should mention this score was generated using a vendor-supplied evaluation framework across a test set of, I think, 98 prompts.
Right. So we always want to see independent third-party validation eventually.
Of course. But understanding what an artifact score of 0.28 actually means in practice is vital here. Visual artifacts are all those weird immersion-breaking errors we talked about earlier.
The melting walls, the flickering textures, the sudden appearance of extra limbs.
Exactly. The artifacts are moments where the model fundamentally forgets what an object is supposed to be. So a low score of 0.28 means the model is drastically reducing those visible glitches.
Which is great.
But it's not just about cleaner pixels in a still image. When you combine that high-fidelity pixel generation with cleaner motion vectors, you achieve what we call temporal stability.
Temporal stability. Okay, meaning the video actually obeys the laws of physics over time, right? Like, if a glass of water falls off a table, it shatters on the floor. It doesn't suddenly turn into a bird and fly away.
Exactly. It maintains plausible physics from frame 1 to frame 100.
Yeah.
The object permanence is solid.
Okay, there is another feature here that I found completely mind-blowing, mainly because it targets a frustration I didn't even realize I had with AI generation. It's a feature called automatic duration.
Oh, yeah. This is a game changer.
Right, because normally if I use a video generation tool, there is a hard setting where I have to tell the software, give me 4 seconds of video or give me 10 seconds. Why is forcing a clip length actually a problem?
Well, because forcing a clip length treats the video like a static container rather than a sequence of events.
Okay, explain that.
Think about the transition from simple software to an AI that actually reasons about the real world. If you write a prompt that says, a heavy freight train enters the station, gradually slows down, and comes to a complete stop, that is a very specific sequence of physical events.
Right, and as a human, I intuitively know that a massive freight train takes a long time to stop. It has momentum.
Exactly. But if you are using a traditional AI tool and you force it to render that exact prompt into a strict 3-second clip, the model panics.
It panics.
Well, computationally speaking, yes. It has to cram all that action into 3 seconds. So the resulting video either looks like the train is moving at 1,000 miles an hour and just slamming into an invisible wall, or the clip just abruptly cuts to black before the train even starts to hit the brakes.
Because the timeline dictates the action, which ruins the realism.
Precisely. But with automatic duration, the AI essentially reads the prompt, understands the physics of the action being requested, and says, okay, to make this look realistic, I need exactly 7.4 seconds.
So the action dictates the length of the clip.
Yes. The model handles all the temporal reasoning, it calculates the necessary pacing for a train to organically slow down and stop, and it just generates the exact number of frames required to execute that action naturally.
Which completely removes the guesswork for the creative director.
Completely. You aren't playing around with sliders trying to figure out how many seconds a sunset takes. The model reasons through the physics of the request on its own.
Okay, so let's zoom out and look at the foundation we've just built here. We have a model that guarantees multi-shot continuity. It allocates its computing power intelligently to prevent glitches, and it natively understands the physical timing of actions.
Right. That is a massive leap forward.
It is, but if you are a marketing team or a corporate communications department, a logically sound, glitch-free video of a random train is pretty much useless to you.
Fair point.
You don't need generic stories. You need stories that look exactly, undeniably like your company's specific brand.
And this is where we cross the bridge from creative experimentation into true enterprise utility.
Yeah.
We have to move away from purely text-to-video generation and focus heavily on image-to-video and audio-to-video workflows.
Okay, let's unpack the image-to-video workflow first, because if you are doing product marketing, text prompting is essentially a liability.
It really is.
Right. If I prompt an AI to create a video of a sleek, modern smartphone, it's going to hallucinate a generic phone that doesn't actually exist. It might borrow design elements from an iPhone and a Samsung, but it definitely won't be my company's phone.
Exactly. So the documentation heavily emphasizes starting with a strong reference frame.
Right, the reference frame.
The reference frame is your anchor. It can be a high-resolution product screenshot, a piece of existing concept art, or actual product photography. By feeding that static image into LTX 2.5 before you generate the video, you are providing the model with a structural blueprint.
Okay, there is an example in the materials regarding a SaaS dashboard, like a piece of enterprise software that I really want to walk through in detail.
Yeah.
Because animating user interfaces is notoriously tedious in traditional production.
That was brutal.
Right. If a software company is launching a new logistics platform, what does that traditional video production pipeline actually look like today?
It is an incredibly heavy lift. First, you have a product manager writing a requirements document. That goes to a copywriter who creates a script. That script goes to a designer who creates all the static UI mockups.
Okay, so already a ton of people involved.
And we're not even animating yet. Then, those mockups are handed over to a motion graphics animator. The animator spends days in software, like Adobe After Effects, manually keyframing every single mouse movement, every drop-down menu opening, every data visualization updating.
Sounds exhausting.
It is. Then it goes to an editor, a sound designer. It is this massive multi-week queue just to get a simple 10-second product demo.
And God forbid the engineering team changes the color of a button at the last minute, right?
Oh, if that happens, the animator has to go back and basically re-render the entire sequence from scratch.
Wow. But let's look at how LTX 2.5 collapses that entire pipeline using image to video. So the marketing team starts with a single static photograph or a high-fidelity mock-up of their logistics dashboard.
Right, and they feed that image directly into the model.
And this is where the prompting shifts, right? Because the prompt isn't just describing the dashboard anymore. The prompt actually acts as camera instructions.
Yes, because the AI already knows what the dashboard looks like.
Yeah.
It has the anchor image, so the prompt becomes highly directorial.
Like what? What would you write?
You'd write something like, a modern logistics control tower viewed from a slightly elevated camera angle. Shipment markers move dynamically across the world map while the sidebar interface updates in real time. Slow cinematic push-in. Clean enterprise visual language. Cool studio lighting.
So the model takes the static image and basically turns it into a living, breathing cinematic shot. The camera actually pushes in, the 2D elements gain 3D depth, the markers on the map move, and the lighting interacts with the interface.
Exactly.
But let me push back here for a second, because if you work in design, this might sound a bit concerning. If you just take a flat image and tell an AI to animate it, doesn't it run the risk of looking really stiff? Like, you know those cheap internet banner ads where a static image just slightly distorts and wiggles?
Yeah, the wobble effect.
Right. How is this actually yielding professional brand consistency rather than just looking like a cheap filter?
That is the defining question for large-scale content teams evaluating this tech. And the difference lies in how the foundation model processes the image latent space.
Okay, hit me with the technical details.
It is not applying a 2D distortion effect over your image. It is mathematically projecting your 2D image into a 3D temporal space.
Meaning?
When the camera pushes in, the model is generating entirely new perspectives of your UI elements based on their implied depth. But the reason it is so vital for brand consistency is that the model is mathematically constrained by the anchor image.
So it can't just make things up.
Right. It cannot hallucinate your brand colors. It will use the exact hex codes from the input image. It cannot mess up the padding or the layout of your software's buttons because those elements are literally hard-coded into the starting frame.
So you are basically throwing a leash around the AI's imagination. You are saying, be creative with the lighting and the camera movement, but do not touch the structural reality of this product.
That's a great way to put it. You are treating the AI not as a creator, but as a highly skilled camera operator and lighting technician operating inside a virtual room where your exact product already exists.
Which bridges the gap between static product marketing and cinematic storytelling without ever compromising the strict identity of the brand.
Exactly.
And the anchoring isn't just visual, which is fascinating to me. The audio integration with LTX 2.5 completely redefines how sound is treated in generative media.
It really does.
Because historically, audio in AI video is an afterthought. You generate a silent video, and then a human editor desperately searches for a stock music track or sound effects to slap on top of it in post-production.
Right, trying to make it fit.
But LTX 2.5 natively accepts audio files, WAV, MP3, M4A, OGG, and uses them as a structural component of the generation itself.
It treats audio as a driving latent vector.
Wait, what does that mean in practice?
It means you can feed the model dialogue, a music track, or ambient sound, and the audio actually dictates the visual sequence. The pacing of the generated video, the intensity of the motion, and even the frequency of the camera cuts are mathematically influenced by the audio track you provide.
Okay, let's use the podcast workflow example since we are recording an audio show right now.
Perfect example.
If we wanted to turn a snippet of this exact conversation into an animated video for social media, the traditional route is just painful. We record the audio, we send it to a transcription service, we hand the transcript to an illustrator who storyboards a visual concept.
Yep, lots of handouts.
Then we generate the visuals, hand them to an editor, and the editor spends hours nudging clips back and forth on a timeline, trying to meticulously sync the characters' lip movements or the scene transitions to our voices.
It's an incredibly labor-intensive synchronization process, just highly tedious.
Right. But with the native audio-to-video workflow in LTX 2.5, that process basically implodes. You take the raw audio file of this conversation and you feed it directly into the model along with your reference image or your prompt.
And the audio structurally drives the generation.
Which is wild.
The model hears the cadence of your voice, it detects the pauses, it registers the emotional tone, and it generates a video sequence where the visual pacing matches the audio inherently.
So we jump straight from having raw audio to having a visually synced rough cut, ready for final editorial polish.
Yep.
We are bypassing transcription, storyboarding, and manual timeline syncing entirely.
Yes. And for a business, the impact of that is staggering. You are removing 3 or 4 manual, highly specialized steps from the production pipeline. You are cutting days of turnaround time down to minutes.
And that massive reduction in friction naturally leads us into how forward-thinking organizations are structuring their content teams around this technology. The documentation refers to this new operational model as the iterative factory.
The iterative factor.
Yes. Let's dig into that, because knowing what a model can do technically is one thing, but how a massive enterprise actually deploys it day to day to reduce costs and increase output is where the real disruption happens.
For sure.
According to the architecture of LTX 2.5, the iterative factory is built on 3 specific non-destructive editing features: retake, extend, and reframe.
These 3 tools are honestly what finally make AI video economically viable at an enterprise scale.
Okay, let's start with the most important one, retake.
Sure. Let's say a marketing team is using a traditional AI generator, and they render a beautiful, highly detailed 10-second commercial for a running shoe.
Okay, got it.
It takes a significant amount of computing time to generate. They watch the clip, and it's gorgeous. But right at second number 8, the logo on the shoe briefly glitches and smears.
Oh, so annoying. In the old paradigm, what did they have to do?
They had to throw the entire 10-second clip in the trash, tweak the prompt, and start completely from scratch.
Wow. So they were forced to re-roll the dice on the entire video and just pray the new generation didn't introduce a completely different error in a different spot.
Exactly. Which means they were paying for 10 seconds of GPU compute time over and over again just to fix a 1-second mistake. It was a massive waste of electricity, money, and time.
So how does Retake fix that?
Retake fundamentally changes this by introducing temporal inpainting.
Temporal inpainting.
Yes. If you have a 10-second clip with a flaw at second 8, you highlight only the problematic area in that specific time frame. You instruct the model to regenerate only that isolated section while mathematically freezing the rest of the video asset.
You essentially surgically remove the bad frame and let the AI heal the gap seamlessly.
Exactly. And you can replace just the visual element, just the audio element, or both. The unit of iteration is no longer the entire video. The unit of iteration is just the specific mistake.
The savings in computing cost and human frustration are immense there.
Oh, yeah.
And this philosophy of non-destructive iteration continues with the extend feature, right?
Right. Suppose that same 10-second running shoe commercial is visually perfect, but the creative director realizes the pacing is just too fast. They need a longer lead-in shot of the runner stretching before they start sprinting.
Again, traditionally, you'd have to try and generate a completely new video of someone stretching and hope it somehow matches the lighting and character of the first video, which we know it wouldn't.
Exactly, because the latent context would be totally different. But with Extend, you take your perfect 10-second clip and you ask the model to organically continue the scene either forward or backward in time.
Backward in time. That's cool.
Yeah. The model analyzes the existing frames, understands the motion vectors in the physical space, and generates new frames that perfectly match the continuity. If the runner was about to break into a sprint at the end of the clip, Extend will calculate the physics of that momentum and generate the actual sprint.
And it does this while extending the audio track as well, right?
Yeah.
Maintaining the ambient sound or the pacing of the music.
Exactly. It preserves the holistic integrity of the asset.
And then we have Reframe, which solves what I consider the modern nightmare of multi-channel distribution.
Oh, the aspect ratio problem.
Right. You spend a massive budget shooting a beautiful wide landscape video in a 16.9 aspect ratio for YouTube or a television broadcast. But then the social media team needs a vertical 9.16 version for TikTok or Instagram Reels.
Always.
If you just take a wide video and crack it vertically, you lose 70% of your frame. The subject steps slightly to the left and they are completely off screen. It looks terrible.
Or you have to hire an editor to go in and manually keyframe the video to constantly pan back and forth to keep the subject in the cropped window, which takes forever.
Right. But Reframe eliminates this through dynamic outpainting. You feed your 16.9 master video into the model and request a 9.16 vertical version. Instead of cropping the sides off, the AI looks at the edges of your video and actually generates the missing visual information above and below your original frame to natively fill the new aspect ratio.
It hallucinates the rest of the physical environment that was previously off camera while keeping the central action perfectly intact.
That's amazing. And the documentation states it supports standard ratios like 1.1 for square feeds, 4.5, 16.9, and 9.16. So when you combine Retake, Extend, and Reframe, a content team is no longer treating an AI generation like a disposable magic trick.
No, they are treating it like a highly malleable block of clay. It's an iterative production asset.
But iterating constantly requires a strategic approach to how a company manages its computing resources, doesn't it? You can't just burn your most expensive, high-fidelity compute power on every single rough draft.
You definitely cannot. And that is why LTX 2.5 bifurcates its workflow into fast and pro models.
Let's break down that enterprise pipeline. The fast model is designed for rapid exploration, right?
Right. It's significantly cheaper computationally, and it generates results quickly. A creative director uses fast for storyboarding, testing different camera angles, and dialing in the composition.
It's the equivalent of a pencil sketch. You don't use it for the final product.
Exactly. When the director gets a sequence they love on the fast model, they promote that concept to the pro workflow. The pro model is where the heavy lifting happens.
So maximum pixel fidelity.
Yes, maximum pixel fidelity, strict temporal stability, complex physics. In fact, advanced features like the audio-to-video integration, the surgical retakes, and native 4K HDR or RAW color workflows absolutely require the pro model's architecture.
So if we track a piece of content through an actual corporate marketing department, the pipeline looks very structured. It starts with the creative brief. From the brief, the strategist develops the prompt or selects the anchor image.
Right.
They run that through generation using the fast model to get a dozen low-cost variations. The team does a review, they pick the winner and upgrade it to Pro for high-fidelity rendering.
Yep.
They use Retake to fix any minor hallucinations. They use Reframe to spin out versions for YouTube, Instagram, and LinkedIn. Then they export and distribute.
Now think about what that pipeline does to the bottom line of a marketing department. The cost structure of content creation is fundamentally upended because the initial phase of creative experimentation becomes virtually free.
Right, because in the traditional model, if you want to test 3 different visual concepts for a campaign, you have to fund 3 different physical shoots or animate 3 different massive motion graphics projects.
Which is prohibitively expensive, and that's why brands usually just pick one safe idea and stick with it.
But with this pipeline, testing a dozen radical visual directions costs pennies in API compute time. And once you secure the master narrative, localizing it or reframing it for different platforms doesn't require exponential cost increases.
And the role of the human beings in this pipeline changes too.
How so?
The content strategist moves entirely upstream. Instead of being handed a finished, finalized video by an agency and being told, figure out how to cut this up for social media, the strategist is directly influencing the visual creation process through prompting and image anchoring.
Which means the metrics for success change entirely. We are moving beyond just measuring how many likes a video got. The documentation outlines entirely new key performance indicators, or KPIs, for enterprise content teams operating these models.
Right. They are tracking things like production cycle time, how many hours from brief to final export. They are tracking the reuse rate of specific visual assets.
And my personal favorite, a metric called the generation to approved asset ratio.
Yes. The generation to approved asset ratio is essentially the ultimate measure of your prompt engineers and your model's efficiency.
Explain that one.
It basically asks, how many garbage, unusable generations did the model have to spit out before we finally got the golden frame that we could actually use?
It quantifies the waste. If your team has to generate 500 clips to get one good 10-second video, your ratio is terrible and you are burning massive amounts of compute budget.
Exactly. And minimizing that ratio is exactly why techniques like image-to-video anchoring and the retake feature are so critical. They narrow the possibility space and stop the AI from just guessing blindly.
But all of this operational efficiency hinges on a massive, critical, technical decision that every enterprise has to make before they even start. It is a decision that will define their entire corporate AI strategy.
The big one.
Do you rent this technology from the cloud, or do you physically own the factory?
The deployment dilemma.
Yes, the deployment dilemma. This is where we have to talk about the physical reality of artificial intelligence. Because AI doesn't live in the clouds, it lives on servers that require massive amounts of electricity and cooling.
Very true.
Let's look at the economics of the API versus self-hosting, because the data we have lays this out in striking detail. If a company chooses to use the hosted API, meaning they just send their prompts over the internet to LTX's servers, they get very predictable per second billing.
Right.
For example, generating a 10-second 1080p clip on the fast model costs a little over $1, about $1.30. If you want the high-fidelity Pro model, it's roughly $1.70. Bumping that up to 4K resolution on the fast model hits about $3.
The API route is phenomenal for rapid prototyping, for independent creators, or for agile marketing teams who don't want to deal with IT overhead. You only pay for exactly what you use.
Makes sense.
But the problem with the API is that at an enterprise scale, those costs scale linearly. If you are generating 10,000 clips a month to support a global e-commerce operation, that per-second billing becomes an astronomical line item on the budget.
Which is why LTX provides a completely different path for organizations operating at scale. Self-hosting the open weight model.
Yes.
This means a company can literally download the underlying mathematical architecture of the AI and run it on their own internal hardware. And the licensing structure here is fascinating.
It really is.
The documentation states that any organization with under $10 million in annual revenue can self-host and use the open weights commercially for absolutely free under a community license.
Which is just a massive democratization of production power for mid-sized companies. Now, if your company makes over $10 million a year, you cross the threshold and require a paid commercial license.
Right.
But the fundamental economic shift remains the same. Your costs transition away from per-second cloud billing and instead become fixed costs associated with physical infrastructure, electricity, and the salaries of the engineering team maintaining the servers.
But let's be incredibly clear here, because the term self-hosting can sound deceptively simple.
Oh yeah, it's not just clicking download.
Exactly. We need to talk about the hardware requirements, because you can't just download this model onto a MacBook Pro and expect to run an enterprise video factory. What kind of physical iron does a company actually need to install to run LTX 2.5 independently?
This is where we have to demystify VRAM, or Video Random Access Memory. LTX claims a minimum threshold of 16 gigabytes of VRAM to get the model running.
Okay, 16 gigabytes. To put that in context, a high-end consumer gaming graphics card might have 16 to 24 gigabytes of VRAM, right?
Correct. But the deeper technical documentation reveals a vital caveat here.
Right. 16 gigabytes is basically the absolute floor. It means you can turn the engine on, but you can't really drive the car on the highway.
It's exactly. 16 gigabytes of VRAM allows a lone developer to load the model, generate some short, low-resolution clips, and experiment with the code. It is an accessibility threshold for the open source community, which is great.
But for actual enterprise production workloads.
Right. Meaning a team of artists simultaneously generating long-duration, multi-shot sequences using the Pro model with native 4K RAW color pipelines. For that, you need significantly more power.
How much more?
You're looking at a minimum of 32 gigabytes of VRAM per GPU, and realistically, you are deploying clusters of enterprise-class hardware, like NVIDIA A100 or H100 GPUs.
And those enterprise GPUs cost tens of thousands of dollars each, plus the cooling systems, the server racks. So self-hosting is an incredible capability, but you are absorbing the massive complexity of GPU optimization, containerization, which means packaging the software so it runs reliably across different servers, and constant hardware maintenance.
Which brings us to a really interesting latency benchmark detailed in the reports, comparing the speed of the cloud API against a hyper-optimized local deployment.
Yes, I wanted to pull on this thread because the numbers look almost too good to be true. The sources state that if you request a 10-second clip via the API, the generation takes about 23.7 seconds.
Which is incredibly fast for video generation already.
It is, but then it says that a local deployment can generate that exact same 10-second clip in an astonishing 6.8 seconds.
Generating 10 seconds of high-fidelity video in under 7 seconds means the model is operating faster than real time.
But let me push back hard on this. I read the fine print on that 6.8-second benchmark. They achieved that speed by running the model on dual NVIDIA GB200 superchips.
Big guns.
Those are bleeding-edge, astronomically expensive pieces of enterprise data center hardware. Most developers, and certainly no independent creators, have dual GB200s seating under their desks. So is that 6.8-second figure even a realistic benchmark for anyone to care about, or is it just a marketing stunt?
That is a very valid skepticism. If you install this on a standard workstation, you are not getting 6.8 seconds. However, the benchmark is crucial, not because of the hardware used, but because of what it proves about the software architecture.
Okay, what does it prove?
When an AI model is inefficiently coded, throwing more hardware at it doesn't always make it faster. The software itself creates a bottleneck. By achieving 6.8 seconds on dual DB200s, LTX is proving that the underlying mathematical architecture of LTX 2.5 is wildly efficient. It proves that the software is not the bottleneck, the hardware is.
I see. It's like a car manufacturer proving their engine design can do 250 miles an hour on a pristine, multi-million-dollar test track. Even if you and I are stuck in traffic in a standard sedan, it proves the engineering limit is extremely high.
Precisely. And as Moore's law continues and compute power inevitably gets cheaper and more accessible over the next few years, that benchmark proves that real-time and faster than real-time generative video is mathematically viable in the near future.
Which is mind-bending.
Imagine a video game dynamically generating photorealistic cutscenes in real time based on your specific gameplay choices.
Yeah.
That is what that benchmark points toward.
But for massive enterprise clients, pure speed might actually be secondary to the real reason they want to self-host. Absolute ironclad security.
Security is everything.
The documentation heavily emphasizes the ability to run LTX 2.5 on air-gapped infrastructure.
Yes, air gapping is the ultimate necessity for regulated industries. If you are a multinational healthcare conglomerate, a major financial institution, or an automotive company like Ford working on unreleased, top-secret vehicle designs, using a public cloud API is a complete non-starter.
Because if a marketing team at a car company takes a CAD drawing of a secret prototype that won't be released for 2 years, and they upload that image to a third-party AI video generator to make a presentation.
They have just transmitted proprietary intellectual property over the public internet to a vendor's servers.
Right, and the corporate compliance officer has no idea where that data is physically stored, who has access to it, or worst of all, whether the AI vendor is secretly using that top-secret car design to further train their public models.
The data leakage risk is catastrophic.
But operating LTX 2.5 in a fully air-gapped environment solves this entirely. Air-gapped means the servers running the AI are physically and electronically disconnected from the outside internet. There is no Wi-Fi, no Ethernet connection to the outside world.
The AI model is brought into the internal network on a secure drive, installed on the company's private servers, and the door is locked.
Wow.
The proprietary anchor images, the text prompts, and the generated video assets never leave the organization's secure perimeter. This architectural choice makes high-fidelity generative video a viable, compliant tool for highly regulated, high-security industries for the very first time.
So let's look at the ultimate end state of this technology for a corporation. We have secured the sensitive data on our own air-gapped servers. We have the giant enterprise GPUs humming away in the basement. We have the multi-shot continuity and the iterative factory pipeline.
We got the whole setup.
Right. Now, how do we take this base model and train it to become an exclusive, highly specialized employee of our specific brand? Because the reports we are analyzing emphasize that fine-tuning the model on proprietary data is the ultimate competitive moat.
This is where we graduate from merely running an AI model to truly owning a bespoke production capability. LTX 2.5 is fundamentally designed to be fine-tuned.
Okay, let's talk about how.
The architecture natively supports advanced adaptation techniques like LoRA, which stands for low-rank adaptation, as well as IC LoRA, and full fine-tuning across all input modalities: text, image, and audio.
Let's break down LoRA for the listeners because it is a critical concept to understand when we talk about customizing AI, but the acronym itself is incredibly dense. How does low-rank adaptation differ from just fully retraining the entire model?
Let's use an analogy. Think of the base LTX 2.5 model like a world-class master chef.
Okay, I like food analogies.
Right. This chef has spent years learning how to cook every conceivable type of cuisine in the world. They understand flavor profiles, heat management, and presentation. That baseline knowledge represents the massive, generalized training the model already possesses.
Okay, makes sense.
Now, if you want this master chef to exclusively cook your grandmother's highly specific secret recipe for marinara sauce, you have two options. Full fine-tuning is the equivalent of sending that master chef back to culinary school for 4 years just to learn that one single sauce.
Which seems excessive.
It is. It requires a massive amount of time, energy, and money, and it fundamentally rewires the chef's entire brain.
Which is computationally exhausting and incredibly expensive for a company to do.
Yes, but LoRA, or low-rank adaptation, is a much smarter approach. Instead of sending the chef back to school, you just hand the master chef a very small, highly specific recipe card that they keep in their pocket.
Ah, okay.
They retain all their immense foundational knowledge of how a kitchen works. But when you ask for marinara, they pull out your specific recipe card and execute it perfectly.
So what is the technical translation of the recipe card?
In technical terms, LoRA freezes the massive neural network weights of the base model and simply injects small, trainable rank decomposition matrices into the architecture. It allows a company to aggressively customize the AI's output without needing a supercomputer to retrain the entire foundational system.
That makes perfect sense. So instead of a marketing team constantly typing out exhausting 5-paragraph prompts trying to force a generic AI to somewhat resemble their brand's minimalist aesthetic and specific color palette, the enterprise just trains a LoRA on their actual proprietary visual data.
Exactly. They feed the model thousands of their past commercials, their specific product catalogs, their brand guidelines, and their unique camera conventions.
Wow. So the AI learns the exact physics of how their specific products reflect light. It learns the specific pacing and tone of their corporate communication style.
You are physically adapting the mathematical boundaries of the model to encompass your brand identity.
It is the ultimate difference between hiring a brand new freelance videographer every single morning and having to explain your entire brand history from scratch over a cup of coffee
Hmm?
versus having an in-house master director who has worked at the company for 20 years and just intuitively knows exactly what the brand looks and feels like.
And that proprietary, fine-tuned model becomes a literal asset on the company's balance sheet. It creates a new category of corporate infrastructure.
Which is a huge shift.
10 years ago, a company's intellectual property was its patents and its trademarks. Today, your intellectual property strategy is your AI strategy. By utilizing open weights and techniques like LoRA, organizations achieve true architectural optionality.
Meaning they aren't trapped in a vendor ecosystem.
Exactly.
They aren't locked into paying a closed API provider a toll indefinitely for every single second of generic video generation. They physically own their customized, highly trained production engine.
But, as with all massive technological shifts, solving one bottleneck inevitably creates a new one further down the pipeline.
Right. Always.
The documentation we are reviewing is very clear about the massive organizational challenge that emerges when creation becomes essentially instant and infinite.
Right. Because if a small creative team of 3 people, utilizing an air-gapped, fine-tuned model and the iterative factory pipeline, can suddenly generate 100 times more content in a single week than they used to produce in a year.
Because all the mechanical, tedious animation and editing is automated.
Right. Where does the friction go?
The friction moves entirely away from creation, and it slams directly into governance and approval.
Ah, of course.
If you can generate 1,000 variations of a commercial in a day, how do you decide which one actually goes on television? A technically perfect, temporally stable, glitch-free video generated by AI can still be a terrible piece of storytelling.
Or it might drift just slightly off brand in a way that a computer can't detect, but a human instantly feels.
Precisely. So organizations are going to need entirely new governance frameworks for scaling these proprietary media models. It's not just about installing the GPUs. It's about establishing rigorous bureaucratic standards for brand consistency.
And they need strict protocols for IP provenance, right?
Yes, provenance is going to become a massive legal focus. When an employee generates an asset, the company needs an immutable log tracking exactly which anchor images were used, which audio files drove the generation, and which specific fine-tuned LoRA was active.
Because if a copyright claim arises, the enterprise must be able to prove exactly how the AI arrived at that specific output.
Exactly. It really requires robust human review systems. The competitive advantage in the market is no longer going to belong to the brand that can generate the most AI video. Video generation will be a commodity.
So what's the new advantage?
The advantage will belong entirely to the team with the most ruthless, efficient human approval systems and distribution pipelines.
We are witnessing the maturation of the medium. We have moved from, look at this funny AI toy that makes videos, to generative video is the new underlying infrastructure of digital communication.
It's a whole new world.
We have covered an incredible amount of ground today, diving deep into a technology that is reshaping an entire industry. We started by looking at how multi-shot generation and the intelligent compute allocation of diffusion fidelity rendering finally solved the frustrating slot machine problem.
Giving creative directors mathematically guaranteed, continuous, logically sound storytelling capabilities.
Yes. And we explored how utilizing image-to-video anchoring and native audio integration allows enterprise brands to maintain absolute rigorous consistency.
Right, mathematically preventing the AI from hallucinating product details and essentially collapsing traditional multi-week production timelines into a single afternoon.
We walked through the economics of the iterative factory, showing how teams use retake, extend, and reframe to surgically heal specific flaws rather than throwing expensive computing time in the trash.
And we broke down the massive, complex enterprise implications.
The reality of self-hosted VRAM requirements, the absolute necessity of air-gapped security for protecting regulated IP, and the ultimate competitive moat of using LoRA to fine-tune a model until it becomes an exclusive expert on your proprietary brand guidelines.
As generative media embeds itself deeper into the foundational enterprise technology stack, the most pressing question for business leaders, developers, and creatives isn't just about what the software can physically render today.
What is it then?
It is about how quickly you can restructure your organizational workflows to harness it safely and effectively.
Exactly. This technology is moving at blinding speed, and the companies that treat it as a foundational utility rather than a temporary trend are the ones that will define the visual landscape of the next decade.
No doubt about it.
So, as we wrap up this deep dive, we want to leave you, the listener, with a final thought to mull over as you look at your own daily workflows.
Consider the long-term trajectory of this technology. If every major global brand eventually successfully fine-tunes their own highly guarded air-gapped video model based strictly on their proprietary historical data, will the entire visual identity of a company eventually be defined entirely by the mathematical boundaries of its dataset?
Wow.
And if that happens, will generic, unfine-tuned, off-the-shelf AI video soon look to the consumer as outdated, obvious, and cheap as 1990s clip art?
It really forces you to step back and ask whether your creative output today relies on hoping for a lucky snapshot or if you are actively building a highly controlled, mathematically sound software pipeline. Thank you for joining us on this deep dive. Keep pushing the boundaries of the tools you use, keep asking the hard questions, and we will catch you next time.